Morning, students. Pushki sir, back with a very important, interesting question in mechanics. So that is the elastic collisions with two mutually perpendicular planes. Actually, I am nowadays discussing too much of mechanics. We will discuss very soon the electricity. Okay, today let us discuss this interesting, important question. My credentials, all of you are aware. So the question is, there are two mutually perpendicular rigid frictionless inclined planes A and B as shown in the figure below. These are the two mutually perpendicular inclined planes. This is the horizontal line. Plane A is inclined at an angle theta with the horizontal, and B is making 90 degree with A. Okay, that's what I have given. A small ball is dropped onto the plane A from a point. This red point is ball, which is at a distance A from the plane A. This distance is A, and B from plane B. So this distance is B. Okay, this distance is B. This is the B distance. This is the A distance. Okay. The line should be a bit, should look straight. Okay, so this ball is located at a distance A from plane A and a distance B from plane B initially, and it is dropped. Okay, all collisions between ball and the planes are perfectly elastic. Then the question is what? Find the ratio of frequency of collisions. Frequency of collision, let me write. Frequency of collision. Let me write that actually. This is frequency of collision. Find the ratio of frequency of collisions of the ball with the plane A and plane B. So the number of collisions per second with A is the frequency of collision with A, and number of collisions per second with plane B is the frequency of collision with plane B. Okay. If this is this ball is dropped like this, so obviously this will be your acceleration will be G, downward, vertically downward acceleration. So this component along the perpendicular to A, component of acceleration of the ball perpendicular to the plane A in this direction, this acceleration component will be G cos theta. This will be G sin theta. Yes or no? So the acceleration component of the ball perpendicular to the plane A is G cos theta. The displacement of the ball along the perpendicular to the plane, what is the displacement? This is displacement. What is the component along the perpendicular? the component of the displacement of the ball along the perpendicular to the plane A is A only. Actual displacement is A by cos theta here, vertical displacement. But perpendicular to the plane, what is displacement? A. What is the acceleration perpendicular to the plane A? G cos theta. Yes or no? Is equal to acceleration perpendicular to plane A. Okay. So what time it will take to hit the plane A then? Straight away in this direction. You know displacement, initial velocity 0, you know the acceleration also. So half g cos theta into t square will be A. That's what I wrote. The time taken is 2A by g cos theta to hit the plane A. Okay. So due to the elastic collision, the perpendicular component of velocity gets reversed. ये जो hit करेगा, जो perpendicular component velocity will be reversed because the elastic collision. So this will move with same angle of reflection theta with the normal. Okay. So, but the perpendicular component velocity gets reversed in direction, but no change in magnitude. So the time taken to rise the maximum height, how much? Now this perpendicular component velocity is same as before collision. So it will go to what time it will take to maximum height? How much? So whatever distance time it takes to fall from here, same time it will take the same vertical velocity. Same normal velocity is going up also, take the same time to go to the maximum height. It will go like this, come to the maximum height from here only. Okay. So what is the maximum height? So time taken to rise the maximum height after collision also will be 2A by g cos theta root over. Am I clear? Just equal to whatever time it takes to fall onto the plane, same time it will take to bounce back to the maximum height from the plane. So both the times are same. So the time period between two successive collisions, like this will like this one will repeat. So what is time period between two successive collisions? Twice of this time. So it is equal to, that is a capital TA, 2 into 2A by g cos theta root over. This is time period between two successive collisions. Yes or no? With plane A. Okay, that is equal to TA, that is 2 times root over of 2A by g cos theta. This is clear? So similarly, this is for A. Okay, so similarly, component of acceleration of the ball perpendicular to plane B, that is g cos 90 minus theta or g sin theta. This is what I have written. And the displacement along the perpendicular to the plane B is B, small b only. Okay. That's clear. So therefore the time taken will be 2b by g sin theta root over, just like I wrote 2a by g cos theta root over here. Okay. For what? To hit plane B. So due to elastic collision, again the perpendicular component velocity gets reversed in the direction after collision, but without change in magnitude. So the time taken to rise the maximum height from the plane B, it will try like this. It's like this, then goes up to same height, again goes like this. So maximum height from, so the time taken for the due to elastic perpendicular velocity gets reversed after collision without change in magnitude. So the time taken to rise the maximum height after collision with plane B. With plane B is equal to this. Yes or no? So the time period between two successive collisions with plane B that is capital TB is 2 times root over 2b by g sine theta. This equation 2 and this was equation 1. Okay? Am I clear? So let the frequency of collision with plane A is equal to NA per second and with plane B is NB per second. Okay? So NA must be 1 by time period and NA is NB will be 1 by time period TB. NA is 1 by time period TA. So NA by NB will be TB by TA. But TB already we know how much it is. This TB, this is B, TB. So TB by TA, TB by TA already you know this is the TB, this is the TA. So only that is the, here the, is it 2 by G same in both the cases. So B sine theta here, this is the TB, TA is A by cos theta, this is B by sine theta. Rest of terms are same. So the ratio will be B by sine theta here, TB, and A is A by cos theta, the root over only. So this becomes B by A cot theta. So NA from equation 3, NA by NB will be TB by TA or BA by A cot theta or B by A tan theta. Okay. So let's take some numerical values. A is 3 meter, B is 4 meter. Let's say this is 3 meter, B is 4 meter, theta is let's say 37 degree, just to give easy numericals. So NA by NB will be B by root over of B by A tan theta. So root over of 4 by 3 tan 37. Tan 37 is almost 3 by 4. 4 goes up 3. So 4 by 3 is the NA by NB. So 3 NA is 4 NB. What to get from this? For every 4 collisions with plane A, that is 3 collisions will be with the plane B. So this is the physical meaning of this ratio of the frequency of collision. Understood this? So you must be knowing in inclined plane, this term known as the maximum height from inclined plane. This perpendicular distance is known as the maximum height from the inclined plane. Yes or no? The same thing I am writing. When I am writing here, the time taken to maximum height means that is the to height the B, small b for the plane capital B, and similarly for this maximum height is small a from the plane A. Okay, let me write also here with A. Okay, so this is clear to you. So very simple question, looks difficult but very simple if you apply the proper concept. You were clear about the vectors very clearly. You are very clear about the vectors. For you it is a cakewalk. I always insist, be very strong in vectors if you want to do well in physics. Okay? Am I clear? So anyway, I'll soon come with other topics. I wanted to discuss this because some people are asked me how to solve this type of problem. I told don't do it by normal method, that direct method. This is the actual easiest method to do. Am I clear? I just resolve the components, and since they are mutually perpendicular, the planes given, my job was much easier here. Basically, I could have taken as this is my x, this is my y. But already you have done many things in the projectile motion, so I just took the x direction, y direction motion, x direction motion separately and dealt with this. Yes or no? That you must have understood by now. Okay, this question is clear to all of you. This problem solved. And thus I give you some numerical data. Now things are very clear to all of you. Thank you all. Have a good day. We'll meet very soon again.